Hey, so in this video, we are going to be talking about translations. So let's get your name up there at the top, and let's get right to it. So a translation is when an object is being moved from one location to another without any kind of rotations. Okay? This is normally occurring on the coordinate plane. The figure's angle measure and side length are preserved. Now we said in the last video that if the figure's angle and measure and side lengths are preserved, then that means that it is a type of isometry. Okay, so isometry is one of those words that we're going to be tested on. Okay, so a basic translation is we'll have some kind of horizontal component as well as a vertical component. And if you push a horizontal component with a vertical component, it kind of looks like it's a diagonal component. Okay? So most people would say this moves up and to the right. Or you can say right and also up. Okay? So you can think about that as two different translations if you want. So the pre-image, let me fix my camera. Okay, hopefully that works. So the pre-image, ABC is shifted up and to the right to create A prime, B prime, C prime. The wording is A maps to A prime, B maps to B prime, C maps to C prime. In other words, we could write it as a little arrow. Typically, we don't write it like this, though. Typically, what we would say is that triangle ABC maps to triangle A prime, B prime, C prime. Okay, so this says the translation on a coordinate plane. When a pre-image is constructed on a coordinate plane, we use ordered pairs that form this figure to translate. So remember that an ordered pair is in the form x, y, and a transformation is an operation within that ordered pair. So let's look at a pre-image shifting 2 to the right. If we're going to shift 2 to the right, then that means that we would take x, y, and we would add 2 to the x component. Why did we add 2 to the x coordinate and not to the y coordinate? Well, we only shifted right. We only had a horizontal component. We did not say that it moved up or down. It doesn't move up or down. Okay, so that's one way you can answer that question. All right, the next part says a pre-image that's shifting up to. Well, that means that we would take our xy coordinate and shift it up to, so that means that I would have the resulting x, comma, y plus 2. So why did we add 2 to the y coordinate and not the x coordinate? Well, this time we only shifted up 2. It doesn't move left or right. Okay? So let's work through some of these quick examples. If this says I want to shift left 5, then I would get x minus 5, comma, y. If I wanted to shift up 3, remember y is the one that shifts things, so y plus 3. All right, I said y is the one that shifts things up and down vertically, right? We're going to try this one on your own. shift right 3 and up 2, well, right 3 would x plus 3 and also up 2, so y plus 2. Shift left 1, so x minus 1, and then down 6. Well, we've went up a bunch of times, but we haven't said down yet. So this time we're going to say down, so minus 6. Okay, and then try this one on your own. I'll show you the answers in just a minute. So hit pause, do these problems, and they magically show up. There they are. So hopefully you got those right. And if you didn't, that's okay too. It's still early in the game. So here we go. Example 9. We're going to shift right 3 and up 1. So every single point, right 3 and up 1. Right 3, up 1, right 3, up 1. Connect the dots. Next one. Now we have to think, what does this say? Well, what it really says is left 2, down 2. Okay, left 2, down 2, left 2, down 2, left 2, down 2, left 2, down 2. Now a lot of people would have gotten confused on that because the shapes overlap a little bit, but there you have it. That's okay if they overlap some. You're going to try this one on your own. If you need to pause the video, that's fine. I'm going to go to the next one. It says x plus 3, y minus 1, right 3, down 1, right 3, down 1, right 3, down 1, right 3, down 1, and we draw that square. That's all you do. So pause the video and give that one a try on your own. And shazam, there it is. All right. I've shifted left 1 and up 3 on all of those points. So in this last part, all we're asked to do is describe the transformation, and we're supposed to be describing it with mathematical notation. Okay? So basically what I need to do is just pick any one of these points and travel from the one without the apostrophe to the one with the apostrophe. Now instead of going diagonally, I'm going to go horizontal and then vertical. In other words, I'm going to go right and then I'm going to go down, because that's the way my coordinates are always written. So every point in this figure on the left has been moved to the right. So it'll be x plus 1, 2, 3, 4. X plus 4 units. And then it's been moved down 2 units, so we're going to say y minus 2. And that'll be your translation. Okay. So let's go ahead and put point, let's just pick B and map it to B prime. On this one, it might be, you might want to go up and then to the right, but just be very careful if you do that. Because yes, even though it's up 2, and that's the way your mind will typically think, every coordinate pair is written as x comma y. So we need to talk about the x. How far did it go to the left first? So 1, 2, 3, 4, 5. It went 5 units to the left, so x minus 5. And then it goes 2 units up, so y plus 2. That'll be your answer for example 14. So let's look at this little note here at the bottom. Looks like they tried to stick something important down here at the very end. All of the translations so far preserve distance and angle measure. What are those translations called again? If you are thinking isometries, then you're right on it. All right, those are called isometries if they preserve distance and angle measure. Therefore, we can say these shapes are called congruent. Okay, and we're going to talk about congruency in the next chapter, in the next section especially. All right, that's it for this video. That video is all about translations. I hope you enjoyed. See ya.